Assalamu alaikum. This is chemistry 11th, and our today's topic is Heisenberg's uncertainty principle. Now, as far as this principle is concerned, this principle it gave a severe blow to the Bohr's postulate, where he said that electrons revolve around the nucleus in a well-defined circular path in which its position as well as its momentum or velocity can be well defined. But as far as mm, this principle is concerned, it was given by Heisenberg in 1927. Werner Heisenberg, he was a German physicist, and he pointed out that we can never measure simultaneously the exact position and exact momentum of a microscopic particle like electron. And this principle is stated as that it is impossible to measure simultaneously the the exact position and exact momentum of a microscopic particle like electron with absolute accuracy or certainties. So this is totally against or it is contrary to what Bohr said that we can measure both position as well as the momentum of the electron in an orbit. This is what Bohr said, but this principle is totally contrary to what Bohr pointed out. Now mathematically, now this principle can be put as it is the product of this delta x into delta p is greater than and equal to h by 4 pi. Here delta x it represents the uncertainty in position, and delta p it represents the uncertainty in the momentum, and h by 4 pi it is constant. Now this sign that is greater than and equal to it represents us here. It means the product of these two, that is the uncertainty in position and uncertainty in principle. Uncertainty in principle can be either greater than this h by 4 pi, or it can be equal to h by 4 pi, and it can be never less than h by 4 pi. Now if we look at this expression here we see the product of the two, that is this is the uncertainty in position, and this is the uncertainty in the momentum. It is greater than and equal to h by 4 pi. Now if this uncertainty in position, that is delta x, if it is small, that means certainty, or we can say certainty in position will be large. Now in that case we say the position of the particle can be measured accurately, but as far as this delta p is concerned, that is the uncertainty in position would be large. That means the measurement of its momentum becomes uncertain. Number second, this is the first case. Now second case is if this is small, if the uncertainty in this momentum is very small, that means the certainty in the momentum will be very large. So in this case the momentum of the particle can be measured accurately, but delta x in this case, that is the determination of its position, that means the uncertainty in the position would be large. It would be large, which means the measurement of its position becomes uncertain. Now if this delta x, or that is this uncertainty in this position, if it is equal to 0, then the position of the electron can be located with absolute accuracy, but this uncertainty of this momentum in this case it would be infinity. This term would be infinity. That is, the momentum or the velocity of this microscopic particles, like electron, cannot be measured at all. Now, as far as the reason behind, as far as the reason behind this is concerned, the reason behind as far as the reason behind this is concerned, we see here that in order to locate an object, an object can be seen only by illuminating it with a light consisting of photons, and the reflected photons from the surface of this object, they reach our eye, or a measuring device, and give us the perception of that object. They give us the perception of that object. Now, according to the principle of this optics, the accuracy with which a particle can be located, it depends upon the wavelength. It depends upon the wavelength of the light used for illumination, or wavelength of that photon which is used for illuminating that object. Now, the uncertainty, now, as far as this uncertainty in position is concerned, it is given by plus minus lambda, that is the wavelength. Now, if we use the shorter wavelength, and if we use the photons of shorter wavelength, greater, in that case greater would be the uncertainty, or greater would be the accuracy in which we can measure the position of that particle. But shorter wavelength, but when the wavelength is shorter, it means high frequency and high energy of the striking photon. Now, this will displace the electron from its normal path. Now, this is the original path of the electron. So once once the incident photon of a very short this wavelength of and a large frequency, once it hits this photon, it brings about a change in its direction. Now, the electron will get displaced towards this direction. This is the new path of the electron after collision with the photon, and this is the expected path of and this is the expected part of the electron. Here we see this is how incident photon strikes this electron, and it is viewed with the help of this microscope. Now this is now once this photon strikes this short wavelength photon strikes this electron, it will bring about because of its high this frequency, it will bring about a change in its normal path, and both speed as well as its direction, they get changed. This is because shorter wavelength of photon, it means a large momentum of that photon. This photon on collision with the electron will impart its momentum to the electron at the time of impact, and bring about a change in its velocity. So the velocity of this electron, it will get changed. Now, if we decrease the momentum of the incident photon, that means if the momentum of the incident photon is decreased, that means we are decreasing the frequency of the incident photon. In that case, the wavelength will get increased, and there will be a greater in uncertainty in measuring its position, because in that case the velocity of the electron remains same, and the determination of its position becomes uncertain. So we cannot this means that we cannot see the microscopic particles like electrons without disturbing it, or without disturbing them. Now in case of these larger objects, or in case of macro objects, or bigger objects, this problem doesn't arise, because photons being very small or too small will not displace such objects. So both position and the moment of such objects can be determined simultaneously with absolute uh, uh, accuracy. As far as the impact of this uncertainty principle is concerned in our daily life, and now it has this uncertainty principle has got no impact on our daily life, because it is applicable to only to the microscopic particles like electrons, protons, neutrons, etc., which cannot be seen through naked eye. Now, it doesn't apply to bigger or macroscopic particles. So this principle has got no impact on our daily life. So this is for today. I hope that you would have got it. This is so in so lastly we can conclude that the two terms, that means the position and this momentum of of a small particle or microscopic or particles cannot be determined simultaneously with absolute accuracy. Thanks this for today. I hope that you have got it.